I was conducting a standard supply chain audit for late 19th century industrial projects. My goal was simple: compare raw material orders against finished construction volumes to model efficiency. I pulled the ledgers for the Adams Power Station at Niagara Falls, expecting the math to balance. It didn't. To line a pit 140 feet deep requires millions of bricks. The orders weren't there. Then I checked the excavation logs. They only hauled away 40% of the rock they claimed to dig. The math was not just off. It was a physical impossibility. They didn't build the station from scratch. They found it. And once I realized the paperwork was a lie, I knew I had to look at the ground itself. I did not start this investigation looking for lost civilizations. I wasn't looking for secret technology, and I certainly wasn't looking for a conspiracy involving the foundational myths of the electrical age. I was looking for receipts. My background is in industrial, logistics, and historical supply chain analysis. It is dry, repetitive work. It involves looking at the raw tonnage of material orders: steel, Portland cement, fired brick, quarried granite, and cross-referencing those orders against the finished volume of major construction projects. The goal is usually to create efficiency models for modern firms, using historical data to predict waste ratios. You look at the Empire State Building, you calculate the steel ordered versus the steel installed, and you find a consistent margin of error. You look at the Brooklyn Bridge, you check the limestone tonnage, and the numbers balance. Construction, even in the 19th century, was a business of ledgers. Nothing gets built without a paper trail, because nothing gets built without someone paying for the materials. That was the mindset I brought to the audit of the Cataract Construction Company and the Niagara Falls Power Company. I was trying to build a data set on late 19th century masonry efficiency. I wanted to see how the introduction of large-scale dynamite excavation changed the ratio of labor hours to cubic yards of removed debris. It was supposed to be a standard data entry job. I pulled the digitized ledgers, the site manager logs, and the procurement orders for the years 1892 through 1896. I had a spreadsheet open on one screen, and the architectural schematics of the Adams Power Station No. 1 on the other. The Adams Station is famous. It is the birthplace of the modern hydroelectric grid, the site where Nikola Tesla and George Westinghouse proved that alternating current could be generated at scale and transmitted over distance. The central feature of the station is the wheel pit. This is not a simple basement. It is a massive, slot-like canyon carved directly into the solid dolomite bedrock. The dimensions are staggering. It is nearly 200 feet long, 20 feet wide, and drops 140 feet, straight down into the earth. It is a cathedral of negative space, lined from top to bottom with heavy, multi-layered brick masonry. I started running the numbers on that brick lining. To line a chamber of those dimensions, assuming a standard 4-layer industrial course for waterproofing and structural integrity, you need a specific number of fired bricks. I calculated the surface area of the walls. I calculated the curvature of the arches. I accounted for the mortar volume. The total requirement came to millions of bricks. I turned to the procurement ledgers to find the orders. They weren't there. I found orders for the superstructure, the beautiful limestone building that sat above ground. I found orders for the slate roof tiles. I found invoices for the copper windings of the dynamos and the steel for the penstocks. But for the massive, intricate masonry lining of the deep pit, the ledger was effectively blank. There were small, sporadic orders for repair brick and sacks of quicklime, but nothing that approached the tens of millions of units required to build what exists in the ground. At first, I assumed the records were incomplete. It happens. Warehouses burn down, files get lost. So I switched my focus to the excavation itself. If I couldn't track the bricks going in, I would track the rock coming out. The official narrative states that the wheel pit was blasted out of solid rock between 1892 and 1895. To remove a volume of dolomite that is 140 feet deep, 20 feet wide, and 200 feet long, plus the miles of lateral tunnels and the massive tail race tunnel that runs under the city, you are talking about hundreds of thousands of tons of debris. This was the era of horse-drawn carts and early steam railways. Moving that much rock leaves a mark. It requires a fleet of wagons, dumping permits, land to put the spoil, and men to haul it. I found the labor payrolls. I found the debris removal logs. And that's when the first cold feeling of unease settled in my stomach. The debris removal logs accounted for less than 40% of the volume of the whole. I ran the calculation 3 times. I checked the density of dolomite. I checked the capacity of a standard 1890 wagon. The numbers refused to budge. According to the company's own records, they hauled away less than half of the rock they claimed to have dug. Where did the rest go? You cannot hide 60% of a mountain. You cannot evaporate hundreds of thousands of tons of stone. There were only 2 possibilities. Either the Cataract Construction Company, a venture backed by the most meticulous financiers in the world, including J.P. Morgan, failed to record the majority of their expenses and labor. Or they didn't dig the hole. They cleaned it out. That was the thought that made me stop typing. It seemed absurd. It seemed impossible. But once the idea took root, I couldn't go back to the spreadsheet. Closed the ledgers. I stopped looking at the numbers and started looking at the pictures. If the paperwork was a lie, or at least a carefully edited half-truth, then the photographic record was the only place left to look. I told myself I was looking for evidence of the missing spoil piles. I told myself I was just trying to resolve a clerical error. But deep down, the obsession had already begun. I turned to the Library of Congress digital archives. I pulled up the panoramic plates from 1893, 1894, and 1895. These are high-resolution scans derived from large-format glass plate negatives. The detail is excruciating. You can count the rivets on a steam shovel. You can read the time on a pocket watch. They are often cited as the definitive proof of American industrial might, the visual record of man conquering nature. At first glance, they look exactly like what you would expect. Men in bowler hats and suspenders, wooden gantries, cranes, smoke, and dirt. It looks authentic. But then I started to zoom in. I spent nights just staring at the texture of the walls in the deep pit. In a photograph dated October 1893, captioned, "Excavation of the main wheel pit," we see a group of workers standing on a debris pile at a depth of about 80 feet. The caption implies they are in the process of blasting and lining the shaft. But look at the walls behind them. The brickwork is perfect. It is seamless. But more importantly, it is weathered. I checked the grain of the image to ensure it wasn't a developing artifact. It wasn't. The film grain was sharp and consistent. The details were physical. I saw calcification deposits, white streaks of mineral buildup, running down the face of the brick. I saw water staining that had darkened the mortar joints. I saw erosion on the corners of the masonry blocks. How does a wall that was supposedly built 3 months ago show 30 years of mineral buildup? How does new construction look like it has been subjected to decades of water exposure? I moved to another photograph. This one showed the construction of the lateral tunnels, the smaller arched passageways that branch off the main pit. In masonry construction, especially when building a load-bearing arch, you need a form. You need a wooden framework, usually heavy timber, to hold the bricks in place until the keystone is set and the mortar cures. In the 1890s, this was non-negotiable. You would expect to see the tunnels choked with timber scaffolding. There are no forms. In image after image, the arches are simply there. They emerge from the rubble piles, fully formed. The workers aren't standing on scaffolding laying brick. They are standing on piles of loose rock, holding shovels, clearing debris away from the arches. The interface between the work and the finished product is wrong. In a true construction photo, you see the raw edge, the place where the brick stops and the empty air begins. Here, You see the brick disappearing into mounds of dirt. They aren't building the wall up. They are uncovering it downwards. The tools didn't fit the task. I saw men holding long-handled shovels and wheelbarrows, standing at the bottom of a 140-foot shaft. Where are the drills? Where are the pneumatic hammers? The records mention them, but the photos rarely show them in use at the working face. The workers look like archaeologists, not miners. They are posing, yes, photography was slow, and you had to hold still, but their posture suggests they are occupying a space, not creating it. The lighting in these photos is another detail that kept me awake. These were taken deep underground. The lighting should be harsh, directional, coming from arc lamps or flash powder. And while there are shadows, the light fall-off is strange. It suggests a vastness that the camera can barely capture. In one image, looking down the length of the tail race tunnel, the darkness seems to swallow the light completely. But the floor is wet, uniformly wet, and the water is flowing. Why is water flowing through a tunnel that is still under construction? If you are laying brick in a tunnel that runs under a river, keeping it dry is the primary battle. You use cofferdams, you pump it out. But in these photos, the water is there, rushing over the floor, and the walls rising out of it are pristine, vitrified brick. It looked less like a construction site and more like a reclamation project. These records cluster tightly between 1892 and 1896. Before this window, the photographic record is strangely panoramic. Photographers captured the falls, the rapids, the suspension bridges, but they avoided the specific ravine where the plant would sit. After 1896, the photos shift abruptly. We see the exterior of the finished building. We see Tesla sitting in a chair. We see the polished dynamo room with its gleaming floors. The middle of the process, the messy, gritty reality of how the bottom half of the machine was actually built, is represented by this handful of confusing, contradictory images. I needed to know how the experts explained this. I am not a historian, but I know how to ask questions. I started contacting the archives. I reached out to the Niagara Falls Historical Society, to university engineering departments, to the custodians of the industrial heritage records. I didn't go in shouting about conspiracies. I asked about the bricks. I asked about the supply chain data. I asked about the mineral buildup in the 1893 photos. The response was a pattern of polite dismissal. It wasn't that they were hiding a secret in a safe. It was that they had simply decided not to care. Records from that era are often fragmentary, one archivist told me. The Cataract Construction Company was known for its speed. They likely sourced materials locally, without centralized logging. Locally, you don't source 20 million industrial-grade vitrified bricks locally without a paper trail. You don't quarry half a mountain locally without someone noticing the dust. When I pressed about the weathering on the walls, the response was a shrug. The environment down there is harsh. Humidity is 100%. Things age fast. Things age fast. That was the explanation. Stone and fired clay, materials chosen specifically for their durability, supposedly aged decades in a matter of weeks, because it was damp. I began to realize that the history of the Adams Power Station is not a history of engineering. It is a history of biography. It is the story of men. It is the story of Tesla, the genius. It is the story of J.P. Morgan, the titan. It is the story of Westinghouse, the innovator. The physical reality of the site is secondary to the narrative of the people. The wheel pit is categorized as excavation. It is treated as a hole in the ground, a brute force necessity to hold the turbines. Because it is classified as a hole, no architectural historian studies it. They study the building on top, the Stanford white design with its limestone arches and neoclassical columns. That building is cataloged, measured, and analyzed. The chamber underneath? It's filed under miscellaneous infrastructure. This is how the erasure works. It is not active suppression. It is passive categorization. By labeling the underground system as a sewer, or a tail race, or a pit, they strip it of its architectural status. If it's just a hole, you don't look for the mason's mark. You don't analyze the geometry. You don't question why the bricks are arranged in herringbone patterns that are invisible to the naked eye in the dark. You simply acknowledge it exists, categorize it as Victorian industry, and move on. There is a professional incentive to maintain this silence. The atom station is the cornerstone of the modern world. To question its construction is to question the competence of the founding fathers of electricity. Imagine the disruption if it turned out that Tesla didn't invent the system, but merely adapted it. Imagine the academic embarrassment if the greatest engineering feat of the 19th century turned out to be a refurbishment of something much older. So, the questions are simply not asked. The blueprints for the deepest sections of the facility, the ones that show the connection to the lower aquifer, are frequently listed in the archives as not available for digitization due to fragility. I requested to view them in person. I was told that the section of the archive containing those specific folios was currently undergoing reorganization. A reorganization that, according to the logs, has been ongoing for 12 years. Denied the paper, I went back to the physical measurements. I couldn't go into the pit. It has been sealed since 1961, capped with concrete and flooded. But I could measure what was visible, and I could use the official dimensions published in the engineering journals of the day. The wheel pit is 140 feet deep. The official explanation is that this depth was required to create the hydraulic head, the pressure, needed to spin the turbines. Water falls down the penstock, hits the turbine, spins it, and exits at the bottom. The higher the fall, the more power. But I looked at the specifications for the 4 Niagara turbines installed in 1895. They were designed for a working head of 135 feet. No, they were optimized for a drop of roughly 80 to 90 feet. In fact, the engineers had to install massive, complex draft tubes to handle the excess pressure created by the depth. They had to engineer around the depth. So, why go down 140 feet? Excavating solid dolomite is one of the most expensive, dangerous, and time-consuming tasks in construction. Every foot of depth adds exponential cost. You have to lift the rock higher. You have to pump more water. The pressure on the walls increases. If the turbines only needed 90 feet, why did they dig an extra 50 feet into the hardest rock in New York? That extra 50 feet represents millions of dollars in 1890 currency. It represents years of labor. No capitalist, certainly not J.P. Morgan, spends a fortune digging a hole deeper than it needs to be. Unless the hole was already there. Unless the depth was a feature of the found system, not a bug of the new one. I started looking at the architectural features at the bottom of the pit, based on the rare photos taken before the flooding. At the very bottom, where the water exits into the tailrace tunnel, the brickwork changes. It shifts from the utilitarian lining of the upper shaft to something else entirely. We see high-precision, vitrified brick that has been fired at such high temperatures it becomes almost like glass. This brick is arranged in complex recursive arches. This is a sewer. That is its function. It carries wastewater. It is a space filled with rushing, violent torrents, forever in total darkness. No human eye was ever meant to see it once the valves were opened. Why apply decorative masonry to a dark drain? And it's not just neat brickwork. It is sacred geometry. The arches intersect at specific angles. The ceiling of the tailrace tunnel isn't a simple barrel vault. It is a compound curve, rising to 25 feet in height. The scale is completely wrong for the function. You don't need a 25-foot ceiling to carry water that flows at a depth of 10 feet. You don't build a cathedral ceiling in a storm drain. The aesthetic argument that the Victorians just made things beautiful fails here. They made train stations beautiful because people bought tickets. They made city halls beautiful because they represented civic pride. They did not spend $500,000 lining a submerged, lightless tunnel with recursive geometry for the sake of beauty. I began to measure the ratios. I took the dimensions of the main chamber, 20 feet wide, 140 feet deep, nearly 200 feet long. I compared these ratios to other structures. They didn't match factory floors. They didn't match mine shafts. They matched organ lofts. Specifically, the proportions matched the resonance chambers found in European Gothic cathedrals, spaces designed to amplify and sustain low-frequency sound. The Adams power station wasn't shaped like a machine shop. It was shaped like a speaker. I expanded the search. Was this a unique anomaly? A folly of one eccentric architect? I looked at the Sholkoff power station, built slightly later, further down the river. The Sholkoff collapsed in a catastrophic failure in 1956, sliding into the gorge. The collapse sheared the face of the cliff and exposed the inner workings. In the photographs of the wreckage, amidst the twisted steel of the modern turbines, you can see the rock face. And embedded in the rock, exposed by the landslide, are sections of the same vitrified brick tunnels that were supposedly drilled for the plant, but which seemed to run perpendicular to the necessary flow of water. The collapse revealed a network, not a line. Then I looked at the Canadian side, the Ontario Power Station. The maps show tunnel alignments that don't make sense. They show intakes and outflows that suggest a connection running under the riverbed, linking the American and Canadian sides. To tunnel under the Niagara River in 1900 through fractured dolomite, with the entire weight of the falls pressing down, is technically impossible with the methods they claim to use. They would have drowned. The shield tunneling method was in its infancy. Yet the alignment maps suggest a continuous system, bisected by the river, connected deep underground. The more I measured, the more the official hydroelectric explanation felt like a cover story. A hydroelectric plant is designed to dampen vibration. Vibration kills bearings. Vibration cracks steel. You anchor the machines to stop them from shaking. But the architecture of the wheel pit seems designed to amplify vibration. The shape, the material, the depth, it is a tuning fork. It creates a resonant cavity. If you spin a turbine in that space, you are fighting the building. But if the building was there first, and its purpose was resonance, then the turbines are the intruders. I needed to see if the record reflected this prior existence. If the pit was there before 1892, surely someone saw it. Surely it was on a map. I started pulling the cartographic history of the Niagara escarpment. I found a geological survey map from 1855. It's a hand-drawn survey focused on mineral rights and potential mill sites. In the area where the Adams station would later stand, the map does not show a flat plateau. It marks a series of depressions. The surveyor has labeled them ancient drainage and, more intriguingly, cavities. I jumped forward to 1890. The Cataract Construction Company had just been formed. The new map, commissioned by the company, renames these features. The cavities are gone. In their place is a dotted line labeled Proposed Hydraulic Canal Routes. They took a geological feature, a hole in the ground, and renamed it a proposal. They claimed the existence of the void as their own idea. By 1896, on the official city maps of Niagara Falls, the area is blank. It is labeled simply Industrial Reserve. The cavities are gone. The proposed routes are gone. The land is presented as a tabula rasa, a blank slate waiting for the genius of Tesla. But the erasure didn't stop at the maps. It extended into the language itself. In the mid-19th century, Niagara was a tourist trap, but it was also a place of wild folklore. I found travel guides from the 1860s and 70s. The Traveler's Companion to the Falls, the Echo Guide. These booklets listed the attractions. They mentioned the Maid of the Mist, the Cave of the Winds, But they also mentioned other spots that have since vanished from the itinerary. One guide describes the Great Echo Caves, accessible from a path near Goat Island. It describes a subterranean thunder that can be heard by pressing one's ear to the rock. Another mentions the thunder tunnels, described as natural fissures where the sound of the falls is amplified to deafening levels. By 1900, these names vanish. You cannot find a reference to the Great Echo Caves in any 20th century guidebook. Did the caves close? Did the rocks move? No. The coordinates of the Echo Caves align perfectly with the intake manifold of the Adams Power Station. They didn't fill the caves in. They put a fence around them. They renamed them. The Echo Caves became the intake. The thunder tunnels became the tail race. The public was told that these were new bores, drilled by dynamite and sweat. The memory of the natural wonder was overwritten by the narrative of industrial conquest. Nature became infrastructure. An existing wonder, visited by thousands, was redefined as a new construction. And because the scale of the construction was so massive, people believed it. It is the ultimate sleight of hand. If you find a pyramid, you don't hide it. You build a lobby in front of it and call it a hotel. I looked for the scientific record. Surely, the geologists knew. I found encyclopedias from the 1880s. The Encyclopedia Britannica, 9th edition, discusses the geology of the Niagara region. It mentions singular acoustic phenomena and hollow bedrock on the American side of the falls. It speculates on the existence of a vast, interconnected cavern system caused by water erosion over millennia. Then I checked the 11th edition, published in 1910. The section on Niagara geology had been rewritten. The references to hollow bedrock were gone. The focus was entirely on shelf stability and water volume. The hollow nature of the ground had been erased from the scientific consensus. Why? Because you cannot build the world's heaviest power plant on hollow bedrock. It scares the investors. It contradicts the structural integrity claims of the power company. So the geology itself was retconned. The earth became solid because the bank required it to be solid. I felt like I was watching a magic trick in slow motion, played out over decades. First, they rename the land. Then they fence it off. Then they rewrite the books that describe it. And finally, they wait for the generation that remembers the Echo Caves to die out. But the erasure wasn't perfect. It never is. There are always fragments. There are always scraps of paper that fall behind the desk. And that's when I started finding the newspaper reports. Not the big headlines. Not the front page puffs about Tesla. I'm talking about the back pages. The local beat reporting. The filler text between the advertisements for patent medicine and corsets. I found a digitized reel of the Niagara Falls Gazette from 1892. I was scrolling through October, looking for construction updates. I found a small blurb, barely 3 inches of column space, on page 4. Excavators at the tunnel site break through into a void, it read. Foreman claims masonry found at depth. Masonry. I stopped scrolling. I read it again. Foreman claims masonry found at depth. Not cave, not fissure. Masonry. Man-made stone. I kept looking. 2 weeks later, November 1892. A follow-up piece. Curiosities from the pit, the headline read. It mentioned that workers had retrieved artifacts of copper and slate from the old workings. The tone of the article was casual, matter of fact. The reporter assumed these were perhaps remnants of early French fur trader mines, or maybe indigenous structures. There was no shock. There was no panic. It was treated as a mild curiosity. But think about the implication. They are 80 feet underground, blasting through what is supposed to be solid rock, and they find copper and slate artifacts in old workings. Then, January 1893. The tone shifts. The voids are suddenly referred to as soft pockets in the dolomite. The references to masonry stop completely. The artifacts are never mentioned again. Instead, a specific editorial appears in 1894. It praises the unprecedented speed of the digging. It lauds the engineers for overcoming the unexpected geological challenges. The narrative had been corrected. Someone had stepped in. The discovery had become a construction site. But the physical evidence described in those early reports, the copper, the slate, the masonry found at depth, it had to go somewhere. You don't just throw curiosities back in the hole. You take them home. You put them on a shelf. You sell them. And that is where the paper trail led me next. Not to the archives, but to the auction block. The auction block was where the paper trail went from abstract text to physical reality. Those artifacts of copper and slate, mentioned so casually in the autumn of 1892, had to go somewhere. When construction sites yield historical oddities, those items don't just evaporate. In the 19th century, they were collected. They became desk weights, mantelpiece ornaments, curiosities for the libraries of the wealthy men who funded the dig. And eventually, those men pass away, and their estates are sold. I began tracking the estate sales of former Westinghouse and General Electric executives from the 1920s and 30s. I spent weeks cross-referencing probate records from upstate New York, looking for the specific names of engineers and site managers who were present at Niagara during the crucial window of 1892 to 1896. I was looking for the fragments that slipped through the erasure. The maps could be redrawn, and the guidebooks could be rewritten, but physical matter persists. I found a catalog from an estate sale in 1926. It belonged to a man who had served as a senior procurement officer for the Cataract Construction Company. Listed under miscellaneous industrial curios were items that defied standard classification. There were listings for massive copper helical structures, quartz-inlaid slate plates, and unusual bronze tooling. The descriptions were vague, written by auctioneers who clearly didn't know what they were looking at, but the provenance was always listed as the Niagara site. This is the final phase of the erasure. When an object cannot be explained by the current paradigm, it is labeled as art, or it is labeled as a prototype. A massive, non-functional metal structure becomes a decorative finial. A slate slab with precise geometric cutouts becomes a Victorian curiosity. The language sanitizes the function. I managed to track down one of these items. It is held in a private collection in New England, purchased by a collector of early electrical memorabilia, who believed it to be an unreleased Tesla prototype. The official appraisal lists it as a roof finial from the Adams Power Station. It is a spiral of heavy-gauge copper, roughly 4 feet in height, mounted on a base of non-conductive slate. I was allowed to examine it in person. I brought calipers, a magnifying glass, and a set of cotton gloves. The first thing that struck me was the weight. It is absurdly heavy. Copper is dense, but this was cast solid. For a roof ornament, something that sits 50 feet in the air and is seen only by birds, this amount of heavy copper is a structural liability. But it was the wear patterns that made me hold my breath. If an object sits on a roof in upstate New York for 30 years, it shows specific environmental degradation. It oxidizes. It turns green. It shows the pitting of acid rain and the abrasion of wind-blown dust. This object showed none of that. Instead, the copper was pitted from the inside out. Under magnification, the surface showed the unmistakable microcratering of electrical arcing. The metal hadn't weathered. It had melted and cooled in microscopic pockets, over and over again. Furthermore, the base showed heavy rotational wear around the attachment points, as if this massive structure was not static, but had been subjected to immense torque. This was not a roof ornament. It was a contact point. It was a component of a machine. And given the size, the current running through it would have been catastrophic. Then I found the tools. Or rather, I found the photographs of the tools that still sit in the deep storage maintenance depots of the New York Power Authority. I filed public record requests for inventory lists of the surplus equipment left over from the original 1895 installation. Interspersed with standard wrenches and pipe cutters were listings for heavy maintenance levers. I found a photograph from 1912 showing 3 men standing next to one of these levers. It is a wrench. It is a wrench that is 8 feet long. The jaw of the wrench is sized for a bolt that is 14 inches across. The official explanation for these oversized tools is leverage. In the era before hydraulic torque drivers, the argument goes, you needed a massive lever arm to tighten the giant bolts holding the turbine casings together. You put 3 men on the end of the wrench and you push. It sounds plausible. It fits the narrative of brute force Victorian engineering. Until you look at the metallurgy. The manifest lists the composition of these giant wrenches not as hardened steel, which would be the cheapest and strongest material for the job, but as bronze and beryllium. Bronze and beryllium alloys have a very specific industrial property. They are non-magnetic, they do not spark, and they do not respond to magnetic fields. Why would you spend 10 times the cost to forge an 8-foot wrench out of non-magnetic metal to tighten steel bolts on a water wheel? There is only one reason you use beryllium tools of that scale. The environment you are working in has a magnetic field so powerful that a steel tool of that size would be ripped out of your hands. A steel wrench that size in a high magnetic field becomes a deadly projectile. The existence of these tools suggests that the environment at the bottom of the wheel pit was hostile in a way that had nothing to do with water. It was an environment of extreme electromagnetic force. And yet, the official history of the Adams plant describes it purely as a hydraulic system, where the magnetism was safely contained within the dynamos on the upper floor, hundreds of feet above. The tools tell a different story. They tell the story of a workforce adapting to a pre-existing hazard. I started to see the pattern everywhere. Not decorative, not ceremonial, industrial, but an industry belonging to a different scale, and perhaps a different era. The items were too big, the wear patterns too specific, the materials too exotic for a simple water mill. The newspaper reports of 1893 had mentioned lateral tunnels being sealed due to accidents. The official line was that unstable rock forced the engineers to abandon certain side passages. But I cross-referenced the coordinates of those sealed tunnels with the modern geological survey. The sealed tunnels did not go toward the river where the water source was. They went away from the river. They plunged deeper into the escarpment, away from the intake, away from the tail race, heading into solid rock where no water could logically be harnessed. Why bore a tunnel away from the water if you are building a water plant? And why fill it with thousands of yards of expensive concrete the moment you find it? You don't fill a collapsed tunnel with concrete. You shore it up with timber, or you abandon it. Filling it completely is an act of erasure. It is an act of sealing. Everything I had gathered, the photographs showing aged brickwork emerging from the rubble, the missing ledgers, the oversized acoustic chambers, the erasure of the maps, the non-magnetic giant tools, the copper arcing anomalies, sat in front of me like pieces of a machine that had been taken apart. The official story says this was all built from scratch between 1892 and 1895 to spin a water wheel. The official story says Tesla invented the system and Morgan funded the dig. But the evidence points toward a different horizon. The evidence requires a unifying hypothesis that accounts for the silence, the scale, and the specific physical anomalies that the historical record tries to ignore. What if the Adams power station was not a generator, but a transducer? Consider the possibility that Nikola Tesla did not invent the alternating current hydroelectric system out of thin air in a laboratory. What if he was brought to Niagara Falls because the financiers had found something they couldn't turn on? The hypothesis begins with the geology. The Niagara escarpment is a massive shelf of dolomite, limestone, and shale. Dolomite is rich in magnesium and quartz. Quartz is piezoelectric. When you compress it or vibrate it, it generates an electrical charge. This is not fringe science. This is how a modern quartz watch works. Now, introduce the largest moving body of water in North America, plunging over a cliff, creating a constant, massive seismic vibration. The ground at Niagara is constantly shaking. It is a natural resonance engine. What if a previous civilization, one that understood the relationship between geometry, resonance, and earth currents, utilized this site not by spinning mechanical turbines, but by tuning the rock itself? Under this hypothesis, the wheel pit was never a pit. It was a resonance cavity. Its specific dimensions, 200 feet long, 20 feet wide, 140 feet deep, were not determined by the need to hold machinery. They were calculated to resonate at the exact fundamental frequency of the Niagara Cascade. The water rushing through the deep, specific geometry of the tunnels created a standing wave of vibration. This vibration, amplified by the dolomite and the vitrified brick lining, stimulated the quartz in the surrounding bedrock. The entire wheel pit became a massive piezoelectric capacitor. This explains the media records. The Cataract Construction Company didn't dig the pit in 1892. They found it. The photographs show workers clearing centuries of silt and rubble out of an existing subterranean complex. That is why the bricks look old. That is why there are no wooden forms for the arches. That is why the debris removed doesn't match the volume of the hole. They weren't building. They were excavating. This explains the architecture. The decorative tunnels with their 25-foot ceilings and recursive herringbone arches were not aesthetic follies. They were waveguides. They were designed to channel sound and frequency, much like the pipes of a cathedral organ. You don't put sacred geometry in a sewer, but you absolutely put it in an acoustic amplifier. The depth of the pit wasn't a mistake. It was the required length of the instrument. This explains the artifacts. The massive copper finials with arcing damage were the collection mechanisms. They harvested the airborne static charge created by the ionization of the falls and the resonance of the pit. The giant, non-magnetic beryllium wrenches were used by the original builders, or perhaps by Tesla's team, to manipulate equipment in a chamber saturated with a lethal magnetic field. And finally, this explains Tesla's role. Tesla famously said, "The Earth is a conductor of acoustic resonance." He wasn't speaking metaphorically. He was looking at Niagara. The financiers had this massive, ancient machine buried under the mud, generating a field of power they couldn't capture. They needed a genius to build an adapter. Tesla's turbines were the adapter. He installed mechanical wheels to regulate the flow of water, to mechanically gate the energy that was already being generated by the geometry of the site. He took a free energy resonance system and capped it with a mechanical system. Why? Because of the meter. You cannot put a meter on the resonance of the Earth. You cannot charge a monthly bill for ambient static electricity harvested from the air. The system, as originally designed, was likely a broadcast system. It was free power. J.P. Morgan, who famously cut Tesla's funding later when Tesla tried to build the Wardenclyffe wireless tower, had no interest in free power. He owned the copper mines. He owned the timber for the poles. He wanted a grid. He wanted wires. So they modified the site. They stripped out the original collectors. They sealed the lateral tunnels that went to other, unknown parts of the complex. They installed the clunky, inefficient mechanical turbines, because turbines produce a load that can be measured, regulated, and sold. They took a symphony and turned it into a ticking clock, all for the sake of commerce. They didn't hide the power. They broke the machine to make it profitable. Now, as an investigator, I have to test this hypothesis. It sounds grand. It sounds like science fiction. I have to hold it up against the strongest counter-explanations available. The first counter-explanation is the simplest. The Victorian grandeur argument. This is the official line of the architectural historians. It suggests that the Victorians were simply obsessed with over-engineering. They built beautiful train stations, they built beautiful sewers in London, they built a beautiful wheel pit at Niagara. The missing records are just the chaos of 19th century bookkeeping. The weird proportions are just the result of ego, men building monuments to themselves. I want to believe this explanation. It is comforting. It keeps history linear. But it falls short when you introduce the factor of cost. Victorian capitalists were vain, but they were not foolish. The brick lining alone for the Adams Station cost the equivalent of $50 million today. You do not spend that money on a space that will be submerged in water and absolute darkness for the entirety of its functional life. You put the marble in the lobby. You put the bronze on the doors. You do not put vitrified, acoustically tuned masonry at the bottom of a drain. The grandeur argument explains the limestone building on the surface. It does not explain the subterranean cathedral. The second strong counter-explanation is the future expansion theory. Engineers argue that the pit was dug to 140 feet, far deeper than needed, to allow for future upgrades. The idea was to build the infrastructure once, making it large enough to accommodate bigger, heavier turbines decades down the line. This also sounds reasonable. Forward-thinking engineering. But history proves it false. When the power company did expand, when they built newer plants in the 1910s and 20s, they didn't use the extra depth. In fact, later hydroelectric plants went shallower. They went wider. The trend in turbine technology was toward more compact, efficient units, not massive drops. The depth was never used for expansion. It was a specific requirement of the original layout, a requirement that became obsolete the moment the site was converted to pure mechanics. Both counter-explanations require us to believe in a level of corporate incompetence and wasted capital that contradicts everything we know about the robber barons of the Gilded Age. The resonance hypothesis, however strange it sounds, is the only lens that brings all the evidence into focus. It explains why the bricks were old. It explains why the map was erased. It explains why the tunnels were sealed. But I cannot claim certainty. I cannot declare the mystery solved. There is no smoking gun document signed by J.P. Morgan that reads, "Conceal the free energy device." The hypothesis remains a possibility, the most coherent possibility I can find, but it is not a verdict. Too much of the physical evidence has been destroyed. The auctions scattered the artifacts to the winds. The archives lost the files. What remains is genuinely uncertain. If this was a pre-existing site, who built it? Was it the remnants of an indigenous culture far more advanced than the history books allow? Was it a colonial French venture that stumbled onto something they didn't understand? Or was it something else entirely? A relic of a civilization that understood the physics of the Earth in a way we are only just beginning to remember? I don't have those answers. What I have is the weight of the silence. The Adams Power Station No. 1 is gone. The beautiful limestone building was demolished in the 1960s. The official reason was structural instability and the shift toward the larger Robert Moses plant downriver. But the pit is still there. You can't demolish a hole. Today, if you take the sanitized tourist tours on the New York side, you will see plaques dedicated to Tesla. You will see preserved control panels. You will be told a story of American exceptionalism and the dawn of the electrical age. But you will not be shown the lower levels. The deepest sections of the remaining infrastructure are classified as hazardous. They are sealed off from the public. More importantly, in the 1960s, when the plant was decommissioned, the Army Corps of Engineers filled the bottom 60 feet of the main wheel pit with concrete. Why? The stated reason was to prevent the collapse of the gorge wall. But the pit had stood for 70 years with rushing water tearing through it. Why did it suddenly need to be plugged with thousands of tons of concrete the moment it was turned off? You don't fill a hole to make the ground stable. The rock was already stable. You fill a hole because you don't want anyone to go down there. The pressure of the unanswered questions only grows the closer you look at the modern landscape. Why do modern ground-penetrating radar surveys, conducted by independent geologists near the state park, show vast rectilinear voids extending miles past the known tunnel systems? The radar shows grid-like patterns of empty space beneath the residential streets of Niagara Falls, patterns that look like city blocks. The official maps show nothing. If the technology at the Adams plant was just water spinning a wheel, simple 19th century mechanics, why were the specific acoustic frequencies of the tunnel resonance classified by the Department of War in 1918? I found the declassification logs. The hydraulic data was public. The acoustic data was a state secret. You do not classify the sound of rushing water unless that sound is doing something you don't want your enemies to know about. And perhaps the hardest question of all, if this was just an ordinary power plant, why did the people who built it feel the need to lie about how hard it was to build? The discrepancy in the debris removal logs still sits on my desk. 60% of the rock is missing. It was never dug out because it was already gone. I stand at the precipice of the modern falls. The mist rises, coating the camera lens. The tourists take their selfies. The roar of the water is deafening. But once you know what to listen for, you realize it is not just white noise. It is a frequency. It is a low, continuous hum that you feel in your chest before your ears even register it. It is the vibration of millions of tons of water hitting the dolomite shelf. The machine beneath the ground isn't broken. It's just been muted. The mechanical turbines are gone. The copper coils are in private collections, and the concrete has capped the surface. But deep below that concrete, in the flooded, lightless dark, the vitrified brick arches are still there. The water still moves through the rock. The quartz still vibrates. The earth is still ringing. It is just waiting for someone to plug it back in.